Hello everyone. On this video I'm going to go over some of the commands listed in the Stata tutorial file that you have on Canvas. So this file has uh, important commands about getting started, a do file, and some of the main commands that are related to reading or managing, modifying variables, or creating statistical analysis. So I'm going to choose some of these commands and I'm going to show you how to use it in Stata. So I already have here my do file, as I mentioned before. So anytime we start a do file, you have some general options here. So you have a clear, because you might have a data set already in Stata software, so you want to make sure that you clear it before you start, because otherwise you will get an error message saying that there is already a data in Stata. So make sure you clear before you start, and then set more of. Sometimes when the output of Stata is too long, you don't want to see that output, right? It's going to be like too annoying seeing like screen after screen of commands. So if you want to switch that off, you can type set more off. And if you want like to see all the commands, if you want to see the long string of commands and output, then you can type set more on. Okay, but now I prefer to have it off. The next important step is setting your own directory. So CD here is for setting a directory, and you have to write the directory where your files are located. In my case, on my computer, my username, and then I put my files in a folder called Stata files. It is under the folder documents. Okay, so this line would differ depending on your directory. And then I have here for you two options of importing the data. I can type, if the data set is DTA, which is a Stata format, you can just type use and then the name of the file, which is the California School District data set. You have the description on Stata, and you have different types of or different formats of data on Canvas. So if you are using the DTA, then you have to say use the name of the file .dta. If you choose to use the CSV file, then the command is insheet using the name of the file .csv. As you can see here, I'm like making this part green because I don't want Stata to execute this part. I just want to use the DTA part. If you want to use the CSV file, then just make this part green. You don't want to have Stata asking you, you have already a data in Stata. And then you can see your data set by typing browse. You can show or you can see a summary statistic of your data set by typing describe. You can summarize it seeing the mean, the maximum, the minimum, the standard deviation of the variable student-teacher ratio, STR, and test score, SCR. And then anytime you're not sure about any of these commands, you can read more details about it by typing the word help before the command. So you will find Stata showing you more details about it and examples and so on. This command, if you want to have a scatter plot between test score and student-teacher ratio. So scatter plot, as you know, is just like dots between the two variables trying to depict the relationship between the two. You can also compute the correlation between the two variables, student-teacher ratio and test score. Another way of creating a new variable is to generate. So you can type generate and then give it any name you like. It could be your name, anything, but you want to have a certain name that you remember. If you want to create a variable which is for the test score, of for the classes which are less than 20 students, then you can call it test score underscore low, which stands for the test score for um, class sizes less than 20 students. You can also generate test score high, which is the test score or would be a variable, would go to the variable test score and pick only those test scores that are related to student teacher ratio equal or more than 20. You can also browse your variables and see them as you saw here. I told you can type a browse, but you can also type BR, and then this way you can look at your variables, the one that you just created, test score low and high, and then the original test score, and then the student teacher ratio. And next you can perform a couple of statistical tests. You want to check whether uh, um, test score is equal to 0. Is this statistically significant or not? Whether test score is equal to a certain number, 653. Whether test score low is statistically different than 0 or not. And whether test score high is equal to 0 or statistically equal to 0 or statistically insignificant. And then also you can do this test, which is you want to test a relationship between two variables, right? You want to check whether the average test score of small classes is equal to the average test score of large classes. Okay, it makes sense to believe that small classes would get more attention from their teacher, and hence they would have larger, or I mean higher grades or higher scores. So you want to test whether it is statistically significant equality or not. You can also add unequal, and this one, if we assume that the variance of the two populations is not the same, so students here and there are having unequal variance. And you can also add unpaired if you believe that the observations are independent, right? So if the observations are independent, then you type unpaired. If they are dependent, then you just type paired. And then finally, you can type help test or t-test if you want to read more about it. As I told you, anytime you want to read about any of the commands, here as you have like help summarize, you will read more about it. Help t-test, then you will read more about it. And I have here a link for you in case you want to check more things that you can do with your data set. So let's start. So let's see. Let's take the directory, let's import the data, and this is the first part. As you can see here, I have the data already, and the next part is let's browse the data and let's describe it. And okay, so this is browsing the data, showing us all the data that we have, right? The district, the county, right? So this is a California school district data set. So you have like multiple districts, and you have like scores for the reading score, the math score, the percentage of students learning English, the average income, student teacher ratio, like how many students per teacher in class, expenditure per student, like the government, how much spending per student, and then computer per student, and so on. And this is all about districts. So and this is the summarize command. Okay, so we have the described command, and it's like the storage type, the display format of each variable, and so on. So the summarize would give you like more statistical details about each variable. So how many observations for 20 observations. The average number of students per class is 19.6. So you can say 20 students per class. Standard deviation is 1.89 approximately. The minimum is 14 students, and the maximum is 26 students. Okay, And test score is again 420 observations, the mean is 654, and then the standard deviation is about 19, and the minimum is 606, maximum 707 approximately. Okay. The next thing we can do is, if you want to, I told you, read more about a certain command, you can just click and read more about it, so you will have more details, more links, description. Okay. And sometimes they also give you a link to a data set to try. Here you have examples. Okay, so it's very helpful. Anytime you are not sure about certain command, just type help. If you want to see a scatter plot, you just type scatter between test score and student teacher ratio, and this would give you the scatter plot. Dots, dots, dots. It doesn't seem to be like a meaningful relationship based on these numbers. I mean, like these observations, because I don't think I can fit a line that passes through most of these observations. Like they are too scattered around this plot. Next, correlation. Suppose I want to test the correlation between the two. What we see, it's negative, and it makes sense. The bigger the class, the smaller the test score. So it's negative, right? The bigger the class, so the higher the student-teacher ratio, the lower the test score. So it's negative of 0.226. What else? Yes, here let's generate variable for the test score for the low size class, or for the class that is less than 20, and then one for the class that is greater than 20. Okay, so we have generated both, or additional two variables. We can see them by typing BR or browse, and you can see them. Okay, so this is test score for the low, test score for the high. This is the test score, the original variable, student teacher ratio. So this is like how our two new variables look like. Now we can start performing some tests. So let's say I want to test whether test score is equal to 0. So what we see here is the output, and this output is telling me that, okay, so this output is telling me that, you see the second part of this table, our observations are 420, our mean is 654, standard deviation, standard error, standard deviation, confidence interval. We are testing whether the average of the test score in my sample is equal to 0. I see actually the mean is right here, it's not 0, right? So your null hypothesis is whether the mean is equal to 0. I have three different alternatives. So check the middle one. So this is the two-sided test, and it's telling me the p-value is equal to 0. So in other words, there is a 0 probability that the mean is equal to 0. In other words, we reject the null hypothesis because it's a very small probability. It's smaller than the significance level of 5%, 1%, right, 10%. All conventional levels. So there is a 0 probability that the null is true. So you reject the null hypothesis and you accept the alternative that the mean is different than 0. You also here have the same conclusion. There is a 0 probability that the null is true. So reject the null and accept the alternative that the mean is greater than 0. And here, as we can see, the mean can never be below 0, right? So that means this one is, okay, I better go to the 0 than just making it negative. So in other words, this one is fail to reject the null. There is a high probability that this null true, because actually the null of having a mean 0 is better than having it as a negative. But in our case, you can focus on the ones that make sense, right? Whether this test score is equal to 0, it's meaningless, statistically insignificant, or it's different than 0, so it's statistically significant. Okay, so based on that, based on our conclusion, we reject the null and conclude that the test score is different than 0.